Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PSD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the lecture number 4 of thermodynamics and statistical physics. Okay, in which I'm going to discuss different processes. Okay, like that is isothermal process, a diabatic process, isochoric process, isobaric process, etc. Okay, and also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, and also I would request you, please share my details, my lectures to your friends so that they can also watch free live lectures and get benefited from it. Okay, okay, let's get started. So so first different processes we are going to study. The first is isobaric process. Okay, isobaric process. Isobaric isobaric process. Isobaric process. Okay, so in isobaric process, isobaric means P constant. Okay, P is constant, means pressure is constant. Pressure is constant. So we'll take two system. Okay, this one this is P1 V1 T1. Okay, and this is P2 P2 T2. Okay, this is the one, and P is constant. P is constant. Okay, so this is isobaric process. So in isobaric process, since we know PV equal to nRT, that is the ideal gas equation, right? So from here, uh, since P is constant, right? So V upon T is going to be nR upon P, right? T is constant means that implies V upon T equal to constant. V upon T equal to constant. So from here, this means uh, V1 V2 equal to T1 T2. Okay, V1 V2 equal to T1 T2. This is in case of isobaric process where K is constant. My apology, pressure is constant, P is constant. Okay, so V1 V2 equal to T1 T2. And if you draw the graph, so graph is going to be graph is going to be like this. PV, right? It's P versus V, and here we can see P is constant, means P will be constant like this. P will be constant. Okay, suppose this is V1, this is V2, V0 and 2V0. Okay, so this is the PV graph where you can see P is constant. Okay, for isobaric process. Next is isochoric process. Isochoric process. Isochoric process. Isochoric process means V is constant. Okay, volume is constant. V is constant. V is constant, and these are the system. Okay. This is P1 V1, P1 V1, T1, and this is P2 V2, T2, right? And V is constant here. Okay, so in this case also I would like to inform you, this is, we can say this one, right? Isobaric process, isobaric process, this one, V1 V2 equal to T1 T2, or we can say V is proportional to T. Okay, so in isochoric process, these are the system, and here we can see we have an ideal gas equation, that is Pv equal to nRT, and is the number of mole, and since V is constant, so P upon T is going to be this one, nR upon V, and that part is constant, right? This is constant because V is constant. So you can see from here P1 P2 is going to be equal to P1 P2 is going to be equal to V1 P2. P1 P2 is going to be equal to V1 P2, or my apology, this is, yes, that's correct, it's isochoric, right? So P1 upon P2 is equal to T1 upon T2. Okay, here we in this in isobaric process we have seen P proportional to T, V proportional to T, right? Here you can see P proportional to T, or P1 P2 equal to T1 T2, P1 P2 equal to T1 T2. Okay, next is if you talk about this first law of thermodynamics, that is, we know del Q equal to du plus del W, right? This is the first law of thermodynamics, right? I have explained that already. So right, so from here you can see since in isochoric process V is constant, right? V is constant, this means dV equal to 0, and we know del W equal to PdV, its path function, right? So and dV equal to 0 means del W equal to 0. So in this equation del Q is going to be du plus 0, right? So implies del Q equal to du. So heat is equal to internal energy in case of isochoric process. And in isochoric process, a graph, if we draw the graph, PV graph, okay, V versus P or P versus V, this is going to be like this. Here you can see this is V0, and this is P0, and this is 2 P0. Okay, so you can see here V is constant. Okay, V is constant, that is V0, right? This is the PV graph. Now isothermal process, third is isothermal process. Isothermal process, isothermal process. In isothermal process, T is constant, guys. T is constant. That is, temperature is constant. Temperature is constant. Okay. So it means system is going to be like this. This is for system P1, V1, T1. Okay. And T2, V2, T2. This is pressure, volume, temperature, and pressure, volume, temperature, right? So here, now again we'll use ideal gas equation, that is PV equal to nRT, right? And in this case, T is constant. T is constant. T constant means PV equal to constants because NR are already constant, right? So from here we can see P1 V1 equal to P2 P2. This is for isothermal process, guys. Okay, or we can say P proportional to 1 upon V. Pressure is inversely proportional to V. Okay, this is, or we can write P1 P2 equal to P2 V1. Okay, or we can write P1 P2 equal to V2 V1. Okay, this is the case of isothermal process, guys. Okay, and in isothermal process, if we draw the graph, it is going to be, so first if we, since in isothermal process T is proportional to U, guys, T is proportional to internal energy. Okay, and since T is constant in isothermal process, right, implies and this implies U is also constant because T proportional to U, that implies du equal to 0. So from first law of thermodynamics, in isothermal process, dq equal to du plus delta W, right? And here d is 0 because internal energy is 0, so dq equal to dw in isothermal process. Okay, heat given to the system is used to work done on the system. Okay, well, this is the one, and now I'll draw the graph, isothermal curve. Okay, in PV graph. So this is going to be like this. Okay, this is P and this is V. This is P, this is V. Okay, and isothermal curve is going to be, and in this graph, this is the graph, guys. This is the graph. Okay, P and V both are changing here. Okay, so this is the isothermal curve. Okay, this is called isothermal curve. And also this type of question can be asked in question, and even it is asked. Okay, PV curve is given. Okay, and different isothermal curve are given. Okay, one is this, one is this, and one is this. Okay, not looking exactly the same, but you can understand. So this is like, it's not, these curves are given. Okay, this is at okay, this is at temperature T1. This curve at this is P versus V. Okay, this is at temperature T1. This curve is at temperature T2, and this curve at temperature T3, and we have to find which temperature is greater. So here this says if these curve are given, so if we have to compare the temperature, then I would then T1 is less than T2 and T2 is less than T3, right? Or we can write T3 greater than T2 greater than T1. Okay, so this is the relation. Okay, so which will be more height, right? This T3, the T3, this curve has got that T3 is the highest temperature, T1 is then and T1. So highest temperature will be T3 and lowest temperature will be T1, right? And if it write, we can write in descending order, that is T3 greater equal to T2 greater equal to T1. In ascending order, T1 less equal to T2 less equal to T3. Okay, so this question is asked in question in the examination, guys. So very important curve. Next, and here we have seen that is dq equal to dw, right? Del q equal to del w, work done equal to del q equal to del w, right? So because du equal to 0 in isothermal process, so now we'll find work done. Okay, work done. So work done is going to be, since del w equal to pdv, right? And we know pv equal to nRT. This is the ideal gas equation, right? From here we can find p is going to be nRT upon v. Okay, so del w is going to be equal to this one, p value will put it, right? Del w is going to be n, this is going to be nRT upon dv upon v, nRT dv upon v, will integrate it. Okay, so w is one nRT these are constant into dv upon v. So work done is going to be w equal to this one nRT ln v2 minus v1. Okay, nRT ln v2 upon v1, nRT ln v2 upon nRT ln v2 upon v1. Okay, or we can write nRT ln p1 upon p2, p1 upon p2, because in isothermal we have seen in isothermal in case of isothermal, this one p1 p2 equal to v2 v1, right? So we have just put the value. So this is the work done, guys. This is the work done, very important. Or this is equal to q. Why? Because del q equal to del w, or q equal to w in case of isothermal process, right? Because du equal to 0. Well guys, this is, I hope you have understood it. Next is a diabatic process. A diabatic process. Okay, a diabatic process. A diabatic process. A diabatic process. A diabatic process. This is a diabatic process. In this is isolated process system. Okay, isolated system. Isolated system, or in this case del q is going to be 0. Okay, in this case del q is going to be 0 because this is isolated system, means no heat change with surrounding. Okay, that is no heat change with surrounding. No heat change with surrounding. Okay, and This is a diabatic process. Okay, and first law of thermodynamics is, we know del Q equal to du plus del W, right? Since in a diabatic process del Q equal to 0, so it means 0 equal to du plus delta W, or we can write delta W equal to minus du. Okay, delta W equal to minus du, very important in a diabatic process. Okay, delta W equal to minus du. Okay, next I just wanted to tell you two main thing. Okay, so here you need to understand, if I'm writing these 2 points. Okay, if work done by the gas, means by the system, okay, then in that case work done is going to be plus V, positive. Okay, and in that case, since we have dw equal to minus du, right? So in that case, or we can write du equal to minus del W, right? So in that case, uh, W is positive, right? In that case, in a diabatic process, du is going to be minus del W, because W is positive. Okay, and second, if work done on the gas or on the system, on the gas oblique system, in that case W is going to be uh, minus V, right? W is minus V, means du equal to minus del W, right? So this is going to be, because this is minus, right? So this is going to be plus del W. Okay, work done. So work done means, so work done by the system, work done by the system, then W is going to be positive. Work done on the system, then W is going to be negative. Okay, well, this is the one, and now, so we'll find this, and we have del W equal to minus du, right? And minus du value we know, du equal to Cv ncv dt, right? ncv dt, ncv dt, ncv dt. So we can write del W equal to ncv dt minus ncv dt. Okay, so from here we can find W. So from here ncv dt, right? And and then we can find a work done. Okay, W, that value is I'm going to write it. So this is nr, work done is going to be nr, we can write like this. Okay, so this is, since we have value, Cv value we know, right? Cv value is R upon gamma minus 1, and Cp value is, this you need to note down, guys. Okay, and memorize it, gamma R upon gamma minus 1. So you can directly find the value of W, and this is going to be nr upon gamma minus 1 T2 minus T1. Very important, this is the work done in case of a diabatic process, or W is going to be this one, P2 V2 minus P1 V1, okay, upon gamma minus 1. Okay, so these are work done in a diabatic process. This you can also find out. So this is W work done. Okay, W equal to nr. Okay, this is nr gamma minus 1 T2 minus T1. Okay, and W equal to P2 minus P2 V2 minus P1 V1 upon 1 minus upon gamma minus 1. So these are the work done in adiabatic process. Okay, well, so this is the one. Next, the adiabatic equation, gas equation. Okay, adiabatic, the gas equation in adiabatic. In case of adiabatic, in case of adiabatic process, gas equation is going to be P V to the power gamma equal to constant. P V to the power gamma equal to constant. Okay, or we can write, yeah, this is the gas equation. Okay, this is the in case of adiabatic process, this is the gas equation. Okay, so here or we can write P1 V1 to the power gamma equal to P2 V to the power gamma. So this is one of the form. Okay, now we know here that ideal equation, right? This we know, PV equal to nRT, right? Or we can write that implies P equal to nRT upon V, right? P equal to nRT upon V, and this implies P1 equal to nRT upon nRT1 upon V, and P2 equal to nRT2 upon V. So what we can do is, in this equation we can write in place of P1 we can write nRT1 upon V gamma to the power V to the power gamma equal to nRT2 upon V gamma to the power V to the power gamma, right? NR will get cancelled, and so this equation is going to be after cancelling this one, these two will get cancelled, right? So this is going to be T1 T V to the power gamma minus 1, right? T1 V1 to the power gamma minus 1 is going to be equal to T2 V to the power gamma minus 1, or we can write, so this is in terms of the gas equation in case of adiabatic in terms of T and V. Okay, and this is in terms of P and V, right? Or we can write T V to the power gamma minus 1 equal to constant. Okay, this is the one. There is third form as well, in which we can write this adiabatic equation in the form of P and T, right? So this is now we know this one, right? PV equal to nRT, right? So this implies V equal to nRT upon P, or we can write that implies V1 equal to nRT1 upon P1, and V2 equal to V2 equal to nRT2 upon P2, right? So now what we can do is we can put these values in equation this one, P1 V1, okay, V2, right? So this is going to be, we'll write the equation V1, or we can write here, so this is going to be P1 V1 and this one, right? So this is going to be T1 1 minus gamma T to the power T1 to the power gamma equal to T2 1 minus gamma T to the power gamma. Okay, this is the one, or we can write T1 minus gamma T to the power gamma equal to constant. Right? This is of in terms of P and T. These questions are very important, guys. So you can solve questions, okay, easily if you know these. So you just need to note down if you know this equation P to the power gamma equal to T1 P1 to the power 1 minus gamma T1 to the power gamma equal to P to the power 1 minus gamma and T to the power gamma. Okay, this is the third form. Well, so okay, guys. So this is about a diabetic. These are the main processes. Okay, this is about a diabetic process. And also, guys, you can also find work done by this equation, a diabetic equation. Okay, that is PV to the power gamma equal to constant. Okay, by that you can also find work done. Work done we know work done equal to we know, right? So very simple. Work done equal to del W equal to PdV, right? So from here we can get P value, right? So means P is going to be this one. Let's say this constant is K upon V to the power gamma. Now you just need to put this value dW equal to this one, P K to the power V to the power gamma and dV gamma dV, right? Or gamma dV, and then this one, right? Then you can integrate it, and if you integrate it you will get this value, this one, work done, nr gamma minus 1 T2 nr upon this one, W equal to P2 V2 minus P1 V1 upon gamma minus 1, and this form. Okay, this one, just you need to put this value and you need to solve it. Okay, the simple thing, guys. Well, so this is about work done. Okay, and these are very important processes. Okay, let me check. There is one question. Okay, guys, we'll solve that question in next class. Okay, that is related to a diabetic equation. Okay, okay, guys. So before ending the class, I would request the student who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. And also, guys, I would request you, please share my lectures to your friends so that they can also be able to watch free live lectures and they can also be benefited from my lecture, guys. Okay, okay, guys, thank you so much. Good night. Bye now.